So, welcome to 10.4 part 2. So, we're going to talk about inscribed polygons. So, the inscribed angle was if you took an angle and kind of went out from there. An inscribed polygon is a polygon with all vertices on a circle. So I'm going to make a polygon here. I could put the vertices somewhere on the circle. It's essentially just made up a bunch of inscribed angles. And there you go. You have a inscribed polygon. On the outside of that is the circumscribed circle. So it's the circle that contains all of those vertices. So not all shapes are going to have a inscribed circle per se. Like some shapes, you just won't be able to draw an exact circle that would hit all of the vertices. It's just not going to work. So that's why it has to be specifically an inscribed polygon. So the polygon's in the inside, the circumscribed circle is on the outside. Something to note is that all triangles have a circumscribed circle. So essentially, it does depend on the different shape, but a triangle is always going to have a circle. Just like here, we have this triangle, there's always going to be a circle that you can draw on it. So the next thing we're going to do is the inscribed right triangle theorem. So I just said that all triangles can be, but a right triangle is special. So the inscribed right triangle theorem, we've been talking about right triangles with the Pythagorean theorem, chapter 9. So if a right triangle is inscribed, well, make sure you can see that. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter. So this is always true. So anytime you have a right triangle here, it's that's going to be the diameter. So in this case, I started with the fact that if triangle ABC is a right triangle, all right, then I know that AC is the diameter. The converse of that, as you can kind of imagine, is going to be the switch. So the theorem says if it's a right triangle, then the hypotenuse is the diameter. The converse is going to say if it's the diameter, then you know that it must be a right triangle. So if a triangle inscribed in a circle has a side that is the diameter, then that triangle must be a right triangle, and the diameter is the hypotenuse. All right, so in this case, so I know I'm given a triangle, one of the sides is the diameter, all right, then it has to be the hypotenuse of a right triangle. And lastly, we have the inscribed quadrilateral theorem. Now, something to note, we talked about quadrilaterals and the angles inside. So the angles in a quadrilateral add up to what? So remember, we had the n minus 2 times 180. Quadrilaterals were always 360 degrees. So the inscribed quadrilateral theorem says that A quadrilateral can be inscribed in a circle if and only if the opposite angles are supplementary. So remember, what does supplementary mean? It means they add to 180. So all four angles have to add to 360, but in order for it to fit inside a circle perfectly, the opposites have to add up to 180. So in this case, angle E plus the measure of angle E plus the measure of angle G has to be 180, and the measure of angle D plus the measure of angle F has to be 180. All right? So opposite means across from. We've been working with that kind of phrasing for a while. So let's practice a couple of each of these. So find the value of each variable. So here we have 2x. What is this angle? Well, this is a triangle, and AB is the diameter. So that inscribed right triangle converse said if I have the diameter, it must be right. So the measure of angle C must be 90, so x must be 45. So that must be a right triangle right there, because this is the hypotenuse. All right, here, this next one. All right, it's a quadrilateral and it's fitting inside, so that must mean the opposites are supplementary. So Z plus 80 would be 180, so Z would have to be 100. And Y plus 120 would be 180, so Y must be 60. So you can get more complicated in those expressions, but that's kind of the basic idea. So again, here is another, this is the hypotenuse, so this must be a right triangle. So that means x is 90, but what's y? Well, they all have to add up to 180. So x plus 40 plus y is 180. We have 90 plus 40 plus y is 180. 130 plus y is 180. So y must be 50. Okay. Another one. So again, the opposites have to be supplementary. So x plus 82 is 180. So x is 98. And y plus 68 is 180. So y must be 112. So we're doing that subtraction. Use your calculator if you need to. That's totally fine. And one last one. So this is kind of like getting a little more complicated with an expression. So I have these two. So 10x plus 8x should equal 180. So now I'm looking for x. I have the coefficients, so I'm going to collect like terms. 18x is 180. Divide by 18. X is going to be 10. And then these two together have to be 180. So c plus 2c minus 6 is going to be 180. So if I collect like terms, I get 3c minus 6 is 180. 3c equals 186. Divide by 3, c is going to be 62. So that's just kind of an example of the different inscribed triangles and quadrilaterals and how we are going to work with those. All right, so now you can make sure that you can do your 10.4 homework and get started on that. I will see you on 10.5.